So this is for anyone who is absent or just needs a refresher on chapter 10 of your notes. Before I do anything with you, I need you to take and put these data sets into your calculator and then calculate the mean and median for each data set and draw a box plot specific for each set. And I will tell you that a shortcut for putting in sequences is at the top of your list on top of L1. You're going to type sequence, and you're going to go find that under second stat, which is your list, and then you're going to choose, I believe it's ops, and sequence should be there. It's either math or ops. And so you're going to do sequence. That actually is an E. Why is this not working? You're going to do sequence, and then you're going to type x, comma 1, comma 12, comma 1. Commas can be found above the number 7, and when you hit enter, it'll put that entire sequence into list 1. Okay, so go get mean, median, and box plot for each. Alright, so here's my means and medians and my box plots. Notice on the second one, I did do a modified box plot because I'm showing the outlier, which means this one has to be 19 because it's the next largest number after the or before the outlier. And so now what I want you to notice is the comparison of the mean and median. So up here, they're equal. And if I look at that shape of the box plot, it looks to be symmetric. And so if I were to switch over to a histogram version, then a symmetric would look like this, a bell shape. And I would find out that the mean, so there's my X bar, usually I label it on the bottom, but now I wrote the word symmetric there, and the median, and so I'm going to put that in green, would lie on top of each other. So when the graph is symmetric, those will be equal. If I look at the second set, I notice, oh my goodness, the mean is bigger than the median. And if I look at this box plot, I might notice, hopefully, that it is right skewed. And so looking at the histogram over here, I can say the same thing about it, that it's right skewed, which means if that's the case, that my mean is greater than my median. And that would be a possibility of how they fit with respect to each other. And then on the last one, I notice, oh my gosh, the mean is less than the median. And if I look at this box plot, I might notice that this 50% here is really spread out. And so it's elongated this way, which means that's what the histogram looks like. So I will get a left skewed shape. Again, I can tell left skewed because the tail is on the left, the mouse tail. And so in this one, the mean would be on the left and the median would be on the right. And the whole reason is that the mean is very attracted to those outliers. He's a little outlier lover. And even if they're not outliers, they are extremes. So for example, if I know that the median is 26 here, and I look at the distance between the mean and this end versus the mean and the left end, there's a bigger difference on the left end. And so the mean, he loves those big differences. And so he's going to go after the 2 and really want to be with the 2. And so that's why the mean is coming over here closer to where 2 is. He's attracted to 2. And so that's what we talked about in class the other day, in case you missed it.